All right, today we're diving into something really cool, the HeXquare gyroid model. We're going to see how some pretty complex math and a little bit of creative recycling can come together in a way that is, well, pretty spectacular.
Okay, just take a look at this. It's this incredible, intricate geometric sculpture. It looks so complex, right? Like something that would come out of a high-end design studio. But here's the secret. It's made from something you probably have in your recycling bin right now.
So that's the big question for today, isn't it? How in the world do you turn a flat, humble piece of cardboard into a mind-bending three-dimensional structure like this one? Well, let's find out.
First things first, we need to meet the star of our show, the gyroid. And as you can see, we're calling it tricky for a very good reason. This is a truly mind-bending mathematical surface.
So what is a gyroid? Well, it's this fascinating, infinitely connected surface. What that means is it's a surface that twists and turns through space, creating these amazing internal tunnels, but it never, ever intersects itself. It was discovered by a NASA scientist, Alan Schoen, and it's not just some abstract idea. This structure pops up all over in nature, from the shimmer on butterfly wings to the way polymers are structured. It's a really important shape.
But here's the catch. As amazing as the gyroid is, it's really hard to physically make one. And this quote from the creator of this model really hits it home. Even with all our modern tech, printing a full, smooth model is tough. For a long time, the best way to really get your head around it, especially for learning, has been a paper model. And that, well, that comes with its own set of challenges.
And that, my friends, is where the HeXquare solution comes in. It is just an absolutely elegant template designed to make this super abstract shape something you can actually build with your own two hands.
And this just illustrates the whole concept perfectly. On one side, you've got this very precise 3D printed template, and you use that template to trace the shape you need onto any old piece of thin cardboard. So you go from this high-tech tool to these simple, colorful cutouts made from, cereal and cracker boxes. It's brilliant.
Now let's break down this building block, because this is where the magic really starts. It's basically what they call a hex star. You can see that central hexagon, and then coming off of it, you have alternating squares and triangles. It's these simple, totally familiar shapes that are the key to building the incredibly complex curves of the gyroid.
So we've got our flat pieces cut out. Now for the fun part. Let's see how these transform from flat cardboard into a little 3D cosmos.
The process itself is surprisingly simple. You just need 14 of these little hex stars to make one complete unit. The real magic happens when you start bending those squares up and down in an alternating pattern, and then connecting them. And get this, you build it in two identical halves. That's a clever move, because it makes the final assembly so much easier.
And here is the little stroke of genius that just makes this whole project sing. Instead of messing around with sticky glue or tape, the design was tweaked so you can just use a simple stapler. Apparently, this whole innovation came about when they were trying to bring this model to a group of kids. The stapler just made it fast, clean, and totally perfect for a classroom. As you start stapling those first few pieces together, you can immediately begin to see the structure take shape. Those simple folds and staples start creating that amazing negative space. The tunnels and passages that are the true signature of the gyroid surface. It's so cool to see it emerge. So here you can see the two completed halves, each one made from 7 of those hex stars. They kind of look like these strange, spiky little creatures, don't they? But they're perfect mirror images of each other. And this method is just fantastic because it lets you build all those complex interior connections before you have to close the whole thing up.
Okay, we've got our two halves ready to go. Now let's see what happens when it all comes together. This is really where the math, the art, and the recycling all collide.
And there it is, the finished piece. It's hanging there like a work of art. It is so hard to believe that this started as just flat pieces of packaging, and the random colors and text from the cereal boxes, they give it this incredible kind of unplanned beauty. It's just a total transformation. And I think it's so important to remember where this all came from. This entire elegant design, from the template to the staples, it was all born from a desire to make this abstract geometry accessible and, fun for kids. It was about turning a big idea into something you can actually hold in your hands.
This quote from the designer just says it all, perfectly. You can look at diagrams and computer models all day long, but as they say, you gotta do it to grasp the beauty of it. You have to actually build it piece by piece to truly feel how these amazing patterns lock together in 3 dimensions. The real understanding comes from the making. So what are the big takeaways here? Well, first, that complex math doesn't always need complex tools. Simple stuff works. Second, this HeXquare template is just a fantastic bridge from the abstract to the real. But I think the most important thing is just how powerful hands-on learning is, and how, with a little creativity, you can literally turn your trash into geometric treasure.
So that leaves us with a final thought to take with you. Looking at a project like this, what complex idea, whether it's in science or math or something else entirely, could you bring to life using just the simple, everyday materials you have right at home? It's something to think about. Thanks for tuning in,